All right, so we're going to be reviewing today Unit 7, Integers and the Coordinate Plane. We're going to be looking at a few different ideas here that will help us prepare for the final exam. First thing we're going to take a look at is absolute value. And absolute value, whenever you see these sort of vertical lines here surrounding a number, that represents absolute value, which is the distance to zero. And as we know, distance is always positive. Distance is always positive. All right, so what we're going to do first is determine the value of each expression. Absolute value of 5, what's the distance of 5 to 0? 5. What's the distance of negative 4 to 0? Even though there's a negative in there, distance is always positive. It is 4 away. Now this one's a little different because it has a negative sign outside of the absolute value symbol. So what's the absolute value of negative 6? It's 6, but there's a negative sign outside. We have to keep that negative sign outside, this one right here. So absolute value of negative 6 is 6, but the value is going to be negative 6 because of that negative sign outside. Absolute value of negative 11, distance is 11. Again, we have the absolute value symbol outside, or the negative sign outside the absolute value symbol. So this one's going to be negative 20. And then absolute value of negative 22 is negative 22. Or I'm sorry, is 22. So we're going to sort these numbers from least to greatest. So of these 6 numbers, which one has the least value? So when you're talking about negative, we have 2 negative numbers. Which one of those has the least value? It's the one that's farthest away from 0. So the number farthest away from 0 in the negative column would be negative 20. So I used that one. I'm just going to put a little X above it to show that I've used it already. Then we have negative 6 would be next because that's the only other negative number. And then the rest of them are kind of easier to sort because they're all positive. Then we have 4, 5, 11, and 22. So before sorting them, it's important to find their value because, again, when the negative sign is outside the absolute value symbol, it makes the value negative. All right, let's check out the coordinate plane. Now, quadrants. So if we think back to quadrants, there are 4 quadrants. They're written as Roman numerals. And to find which quadrant is which, oftentimes I'll use the letter C. So I'm gonna use the letter and then erase it. But this letter C can help us determine the order of the quadrants. So quadrant 1 is where we started that C. This is quadrant 1, where all the numbers are positive. X and Y values are positive. This is the second quadrant. The third quadrant, where all the values are negative. X is negative and Y is negative. And then the fourth quadrant we write as IV, like Ivy Leagues we've said before. So those are the quadrants. What we're going to do is we're going to plot these points. I'm going to give them names here just because it might be easier to see them after we put the points on the coordinate plane. Okay, that's an E. Okay, G and H. Okay, so when putting a point on the coordinate plane, the X value is first and then the Y value is second. So we go side to side with X because the X axis is side to side, and then up and down with Y. So we use this little rhyme, up and side to side, then up and down. That is where the point is found to help us put points on the coordinate plane. So A, we're going to go over 3, or over 1, up 3. Over 1, up 3. First number tells us side to side, second number up or down. So that's point A, and that's in quadrant 1. All right, let's check out point B. Side to side to negative 2, and then up 4. That's going to be point B right there. That's in quadrant 2. C, side to side to negative 3, then down to negative 3. That's point C, which is in quadrant 3. both negative, and that's how you can tell too. These are both negative numbers. It would be in quadrant 3. Now D is also both negative, so I know that's in quadrant 3 going into it, but I'm going to put the point on there anyway. We go to side to -2, then down to -4. That's going to be point D. That's also in quadrant 3. And then point E. These are both positive, so it's going to be in quadrant 1. Over 3, up 1. Side to side 3, up 1. It's going to be E. It's a quadrant 1. It looks like a 4, but it's actually a 1. Point F is going to be side to side 2, positive 2, and then down to -4. It's a point F. That's in quadrant 4, our first point in quadrant 4. G is side to side -3, and then up 3. It's point G. That's going to be in quadrant 2. And then point H is a little different. Side to side 0, that's what the first number means. Side to side nothing, up 4. And since H is on an axis, it's not in a quadrant. It's on the y-axis. So it's not in a quadrant if it's on an axis. Perfect. All right, now we're going to name some points based on where they are in the coordinate plane. All right, so again, side to side, up and down, that's where the point is found. So the first number in the ordered pair will be x, and that's going to be the side to side value, and then y is going to be up or down. Okay, if it's up, it would be positive. If it's down, it would be negative. So point A, side to side, if we start at the origin, side to side, we go to 2. So our first number is 2. And then we go up to 7. So A is at 2, 7. Over 2, up 7. B, start at the origin, 0, 0. Over to -4, side to side to -4, up to 6. So its ordered pair would be -4, 6. D, start at 0, side to side to -3, and then down to -3, which is between -2 and -4. So that would be in quadrant 3. It's -3, -3. Point E, side to side. Well, we don't have to go side to side at all. We're not moving side to side to get to E. So 0 would be the side to side, and then we have to go up to 2. So it's at 0, 2, which is on the y-axis. It's not in a quadrant. And then point F, side to side to 7, then down to -5. So it'd be 7, -5. Okay, little ordered pair practice there. Let's check out the next page, I believe. Yes. Okay, so it says below is a plan for a new bumper car ride. Each grid square has a length of 40 feet. What is the total distance around the ride? So what that's saying is this particular shape, we're looking at the distance around it. We're looking at the perimeter. And each one of these, and I'll kind of use this, each one of these little grid squares, the length of this is 40 feet. Okay, that's 40 feet right there. So what we can do is determine how many side lengths this figure is made out of, and then multiply it by 40. So what I'm going to do is I'm going to label the length of each side, and then we'll add up those numbers. Okay, so this first side down here, 1, 2, 3, 4, 5, 6. This has 6 side lengths. This one here is 2. I'm going to kind of go around the figure in order. This one here is 1. And then we have a 2 here. Here's another 2. Another 2. So many 2s. A 3. And 1, 2, 3, 4, 5, 6. This is 6 as well. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So I'm going to make sure that when we add these up, we're going to have 8 numbers. One way to do that is as I'm adding up, I'm going to cross them off just to make sure I've counted them all. So I have 6, cross it off, plus 2, cross it off, plus 1, crossing it, plus 2, crossing it, plus 2, crossing it off. It's just making sure I've counted them all and I have not repeated one or left one out. Crossing 3 off, counting that one, and then the last number would be 6, crossing it off. Okay, let's add these things up. So we have 6 plus 2, which is 8, plus 1 is 9, plus 2 is 11, plus 2 is 13, plus 2 is 15, plus 3 is 18, plus 6 is 24. So again, you'll have a calculator, so you'll be able to count those up using it, or add them up using a calculator, but it's often good to do it in your head maybe, and then check it with a calculator just to make sure you get the same number. I'm just going to double check that. So 6 and 2 and 2, these make a 10. This 6, this 2, and this 2 make a 10, and then we have 3 plus 1 left over, so we have 20 plus 4, which is 24. Now, we're not done because it's 24 is how many side lengths, but each one stands for 40, so we're going to have to multiply that 24 by 40 to get the answer. I'm just going to multiply these through. That's going to be 0 and 0. Placeholder 0 here. 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9. So when we add these up, we get 960, and that's going to be feet. Not squared, because we're not talking about area. We're talking about just distance around the figure. So it's going to be 960 feet, which is, it's about a fifth of a mile. So it's kind of long, I guess, for bumper cars. All right, let's look at the next one. All right, turning a mixed number into a decimal. So there's a couple different ways of doing this. I'm going to show you both, and it depends on what kind of fractions you are working with. So 5 and 4/5. This one's a little easier because if you think about the fraction here, if you can get it to tenths or hundredths, you can easily turn it into a decimal. Okay, so for example, 5 and 4/5. That's just the same as 5 and 8/10. And I'll show you how I got there. So 4/5, I knew I can get to tenths really easily by multiplying by 2, times 2 here, times 2 here. 4 times 2 is 8. So I saw that I can get to 10 easily. And the reason why I looked for 10 or 100 is because once you get to tenths or hundredths, you can easily turn it into a decimal. So 5 and 8/10 is the same thing as 5 and 8/10. So that only works when the denominator can easily get to 10 or easily get to 100. You can just kind of change it to 10, change it to 100, and then write the decimal based on the fraction. Another way to do it, which works for any mixed number, whether it can easily be, you can easily get to 10 or 100, is to swoop it and then tap in the box. Okay, so 6 and 1/8. I can't think of a number I can multiply 8 to get to 10 or 100 off the top of my head. So if I'm going to swoop this thing, 8 times 6 is 48, plus 1 is 49. So this is the same thing as 49/8. Now I'm not done yet, but what I can do is put 49 in the box, in the dividend den, top in the box, and divide by 8. And then that will give me the decimal. This will work for every single mixed number. The other way, those can be a little easier when you're working with easier numbers. 8 goes into 4 0 times.
Happy tour announcement day.
Thank you so much. Thank you so much.
Thank you so much.
All right, I just had a special guest. 8 goes into 49 6 times. 6 times 8 is 48. 49 minus 48 is 1. Got to keep dividing, so I'm going to put a decimal point. Annex is 0. Bring it down. 8 goes into 10. Oh, I got to bring up my decimal point. It goes into 10 just one time. 8 times 1 is 8. 10 minus 8 is 2. Got to keep dividing. So bring that 0 down. 8 goes into 20 twice. 2 times 8 is 16. 20 minus 16 is 4. Need to annex another 0. Bring it down. We're almost done, though, because 8 goes into 40 5 times. 5 times 8 is 40. And there it is. There's the decimal. 6.125 or 6 in 125,000. So, again, what we did is we swooped it, and then we top in the box. We divided it out, making sure the key thing here is that you put that decimal in there before we annex any zeros. All right, last problem here. We're going to order these numbers from least to greatest. We have 4 numbers here. Some are negative, some are positive. We're going to order these numbers from least to greatest. So I'm going to start with a little L here to remind me that that's going to be where the least goes. So when doing this, I'm going to focus first. If I'm going least to greatest, I'm going to focus first on the negative numbers because those are going to be less than the positive numbers. So once I figure out where these numbers go, it'll make things a little easier. All right, well, I have negative 5 and 1/5. And I'm thinking to the last examples we did when we changed mixed numbers to improper fractions. And I'm thinking, like, can I get from fifths to tenths really easily? And I think I can. So I can multiply the top and bottom by 2. So this is going to be negative 5 and 2/10. Shout out to some special guests who, one of which hit a home run last night. So shout out to the special guest. So negative 5 and 2/10, you would write that as a decimal as negative 5 and 2/10. So again, when you get to 10 or 100 easily, you can change that easily into a decimal. Now, our other decimal has a number in the hundredths place. So I want to make this decimal also go to the hundredths place. So what I'll do is I'll annex a 0. So now I'm thinking between negative 5 and 20 hundredths, negative 5 and 15 hundredths, which one has the least value? The one that has the least value is the one that's farther away from 0. So I'm thinking that this negative 5 and 20 hundredths, that's slightly farther away from 0. So I'm going to list that first. That's going to have the least value. Okay, so that one's done. I've sorted that one. Next is the only negative number that's left. Negative 5 and 15 hundredths. Okay? We got 2 numbers left. We're almost there. All right, so now I have 5 and 26 hundredths. I also have a mixed number, 5 and 1/4. Well, 5 and 1/4 has a little nickname, and the nickname for 1/4 is a quarter. So I know that, 1/4 is quarters. So I could write 5 and 1/4 as 5 and 1/4, which would be quarters worth 25 cents. So 5.25. So I didn't have to use my swoop top in the box method because I was able to get those decimals really easily. And again, you'll have a calculator too. So if you wanted to do 1 divided by 4, that will give you the decimal. So to sort these out, which one's least? Well, 5 and 25 hundredths has the least value. Then 5 and 26 hundredths would be next. And there we have sorted the numbers from least to greatest. And we are all set with that. If you have any questions on integers or the coordinate plane, please let me know. If not, hope you have a great day. Hope to see you soon. Bye-bye.